Hello guys, welcome back to Work Energy and Power. So we will be moving forward with work done. Remember, we've got three things that we will be focusing on. We'll be focusing on work done, mechanical energy, work done by non-conservative forces, and also other things such as pendulums and all those rubbish. But currently, we are dealing with work done. When we go to mechanical energy, I'll tell you. So currently we're dealing with work done, and the formula I've actually shown you on the previous video how work done is and how it actually works. So on this video, I will be discussing more about work done so that you can actually understand how it actually works. Otherwise, guys, remember to go and check the link on my bio. Click it to request that we apply for universities, colleges, and bursaries. And also go and tell your classmate about this course that I am actually offering you guys. If you very much like the course, tell your classmate. Remember, I'm trying to be ambitious. I'm just make my dream comes true, guys. Just make my dream happen. Go and tell your classmate, your friends, so that I can reach 20,000 people that visit my page each and every single day, and also those who want to buy my course. Without you guys, obviously, we wouldn't be doing what we are doing, so we do it for you guys. We really appreciate you. Otherwise, let's actually get down to business. Let's look at this. Okay. We are having a block, a 25 kg block, that is actually being pulled by a string under 45 newtons on an angle of 30 degrees. It moves from point P to Q. At point Q, it has a velocity of 12 meters. At point Q is 10.8 meters. It is deaccelerating. It is slowing down. It moves at a distance of 3.5 meters. And the first question we get is draw a free body diagram of this block. How do we draw a free body diagram? So how we draw a free body diagram is we're going to say, okay, we know this thing experiences gravitational force, and obviously this thing experiences frictional force because they did not tell us that this thing is not experiencing friction. It is also going to experience the force applied on that angle, and it is also going to experience some sort of normal force on that angle. And now the question say calculate friction. So we are using the work done formula to calculate friction, right? So remember that the work done is actually work net equals to half mass V final squared minus V initial squared. So on this problem, we're going to have the work done by force applied plus the work done by friction. That equals to 1 over 2 mass V final squared equals to V initial squared. So the work done by force applied, because it is actually on an angle, remember we are looking for this X component. We are not just looking for this one. We are looking for the force applied in the X component, right? So the X component is going to be force applied, the cos of what? The cos of 30 degrees. We are actually looking for this path, force applied the cos of 30 degrees. And then it means that we're going to have force applied on the X direction times change in X, the cos of theta. Let's just leave the work done by friction as it is. And then we're going to have 1 over 2m V final squared V initial squared. So what is the force of applied in the X direction? Well, the force applied is actually 45 newtons, and we're going to have the cos of 30 degrees times what is change in X? Our change in X is actually 3.5 meters. I'm going to have the 3.5 meters, and I'm going to have another cos, which actually comes with the formula. So this is actually moving in the positive direction. As we have seen in the previous video, this is going to be the cos of 0 degrees plus the work done by frictional force equals to 1 over 2. What is our mass? Our mass is actually 25, right? And then what is our V final? V final is going to be 10.8, right? Is 10.8 meters per second. We're gonna have 10.8 meters per second squared minus V initial. Our V initial is going to be 12 meters per second. So we're going to have 12 meters per second squared. So let's actually try to hit this in the calculator and see what we find. We're gonna have 45, the cos of 30, times 3,5, the cos of 0. And we find that this is the same as 136.399 plus the work done by frictional force equals to, let me just hit everything in here. We're gonna have the 1/2 equals to 25, and then we're gonna have 10.8 squared minus 12 squared, and I get a value of minus 342. So I'm going to take this into the other side. So the work done by friction is going to be minus 342 minus 136.399. That actually equals to minus 478.399. But the question said we need to calculate friction, right? Not the, this is the work done by friction. This is not friction, this is the work done by friction. So we need to rearrange this. We're gonna have friction, change in x, the cos of theta. We want to find friction, not the work done by friction, equals to minus 478.399. So what is my friction? This thing moved a distance of 3.5 meters. So I'm gonna have my 3.5. The cos, this thing is actually on the neck. It is friction x on the opposite side, as you have seen in the previous video. This is going to be 180 degrees, and this is going to equals to minus 478.399. So frictional force is going to be cos of 180 degrees. This is the same as minus 1. And then I'm going to divide both sides by 3.5, by minus 3.5. So I'm going to divide both sides by 3.5. And I get that frictional force is 136.68 newtons. That is the value of the frictional force that we actually find. Well, there's actually another way of finding frictional force. Actually, but let me see if it is actually reasonable for me to teach you that method now. Let me just think about it. Let me just think if that is actually a good thing for me to teach you that method now. Bum, 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 bum. Yeah, let me just teach you now, because if I don't teach you now, when am I going to teach you? So this method, guys, I want to teach you now. It is a very important method. We will be using it a lot. So ensure that you understand what I'm about to tell you here. Let me try to re-answer this question using this method. Look, we said the work net equals to 1/2 m V final squared minus V initial squared. Well, this work net is actually coming from F net that actually equals to MA. So in another word, the work net is the same as the work net as coming from this one. Do you understand? So sometimes instead of having to write your answers in terms of this, you might have seen, you see, these things are so long. You see, it is so long, even like your page length runs out. What you can do sometimes is, instead of just jumping into the formula of W net, you can use F net. You can say, okay, F net equals to, what are the forces that are here? The forces that are here, it is the force applied in the x direction and also the frictional force. For that we know that the frictional force is minus. So you're going to say, okay, so the F net is going to equals to, what is the force applied? It's going to be 45, the cos of 30 degrees minus frictional force, right? And then you say the F net is going to be, what is this? So the 45, the cos of 30, it is going to give me 38.97 minus frictional force. So after doing this separately, you're going to say, okay, therefore, work net. This work net, you're going to say it actually equals to what? It actually equals to, okay, before we even get here, let me show you something. The work done by F net, it is going to equals to F net changing X, the cos of theta, right? Until the work done by F, if this was just F, it is still the same thing as this. So even if when it is the work done by F net, it is going to be F net changing X, the cos of theta. It is still the same thing as this. So now here we're going to say, therefore, the work done by F net, it is going to be F net changing X, the cos of theta. Each and every single time when you use F net, theta is always going to be 0 degrees. Don't forget that. Each and every single time when you use F net, theta is going to be 0 degrees. So what is your F net? This is your F net, isn't it? This is the value of your F net. F net is 38.97 minus frictional force. And what is your change in X? It is going to be 3.5. It is going to be 3.5. And the cos of 0 is the same thing as 1. This is your work done by F net. And then you're going to say, but the work done by F net equals to 1 over 2 m v final squared minus v initial squared. So you're going to say, okay, so the work done by F net, you're just going to substitute this. You're going to have 38.97 minus Fk, that equals to 3.5. This is actually going to equals to 1 over 2. The mass is actually 2.5. V final is going to be 10.8 squared, and V initial is going to be like 12 squared, right? Oh my god, this is terrible. Oh, it can actually, okay. So you're going to find this value. What was this answer on the other video? On the other one, let me check. It was minus 342, right? It was minus 342. So I'm going to have 38.97 minus friction. That actually equals to 3.5. So let me divide both sides by 3.5. So minus 342 divided by 3.5. I'm going to get minus 97.71, right? That equals to 38.97 minus frictional force. So minus frictional force is going to equal, so I'm going to take this one to the other side. I'm going to have minus 38.97. That actually equals to minus 136.68. And then this will cancel out newtons. So you find that you get the same answer as we have actually used here. So let me tell you something. Some of you guys might be saying, yo, Marvel, you will say, yo, I love this one better. Hey, this one is confusing, Yana. Trust me, this one is the easiest one. It's just that because I'm introducing you to it now, you will feel like it's too much. But the more we use it, you'll realize it's more easier. Because that one, it is good, by the way. I'm not discouraging it. If you want to use it, it's fine. But you will see as we do more questions that, hey, that one, it's... you know, it will confuse you because you are going to write long values that will take 3 lines. Imagine writing an equation that take 3 lines, right? And you will see what I'm talking about. I'm not exaggerating. Maybe it's because I have an ugly handwriting. I can't write one equation in 3 lines. You will make a lot of mistake. But this one, you are breaking everything down using Newton laws of motions. But otherwise, guys, go and tell your friends, please, guys, I'm begging you, go and tell your friends about this work energy and power course, because I'm trying to reach 20,000 South Africans and non-South Africans, and then even your friends will tell their friends, even their friends will tell their friends. Hopefully I'm going to get to the numbers that I hope to get. Otherwise, guys, enjoy the rest of your day.